The next few slides, I'm going to discuss some of the advances that are taking place in the area of machine learning. I identified four areas in which most of the activity seems to be happening. One is the fear of artificial intelligence is cooling down. I'll elaborate more on each of these things. The second one is there is more focus on FAT issues. FAT stands for fairness, accountability, and transparency. The third area where activity is kind of busy is deep learning, and it is here going to be here for some more time. And most of the activity is involving application of deep learning to areas other than image processing. And the final area is frameworks. When I come to the idea of frameworks, I will explain those things in a second. So these are the four areas where I see most of the activity has taken place in the last 2 years. Okay, let me spend a little time on the fear of AI. Basically, what is happening is wherever I go and give talks, people ask me invariably the question, are the robots taking over? Are we going to lose our jobs to robots? This is a common fear among students who are trying to get into the information technology area and are afraid that their own education will do them in. They won't get jobs afterwards. And that fear is not new. It has been there for some time. People are worried about machines running our lives. It's not uh, ordinary people, well-known people like Stephen Hawking, Bill Gates, Elon Musk. All these people have expressed fears that unless you put some controls on the development of AI, the advances can get us into trouble. So that fear is kind of going down a little because they're beginning to see ways to put controls on AI. Let me elaborate on this. For example, self-driving cars are almost here. I see occasionally a self-driving car on the highway nowadays. And the question is it desirable to have more and more self-driving cars? Are they safe? Desirable in the sense as more and more self-driving cars are there, people are going to lose jobs. People who are driving taxis or even Uber and Lyft and other kind of services, they may lose jobs because of this thing. The other thing is safety. Can we really trust the AI and let self-driving cars roam around the streets? This is a fear that is still there, and people are still worried about how to make this a safe situation. So to answer these two questions, there is a lot of emphasis on how to humanize AI. What do I mean by humanize? Here, what we are trying to do is when we design an artificial intelligence system, you not only want to put intelligence into the system, like IQ type of intelligence, but also emotional kind of intelligence into the system, or EQ. So just like we people have both IQ and EQ, you should have the robotic systems have both of these things to reflect the human considerations. And finally, should we regulate AI, or are the current guidelines adequate? And once again, even from the days of Isaac Asimov, people are worried about how to regulate AI, what kind of rules the robot should follow. And this effort will continue to grow as more and more robotic systems permeate our life. So this area is still evolving, and it will take some more time to understand where it is going. Okay, let me spend a little time on the fat issues that we were talking about. Basically, what is happening is most of the systems that we are designing right now are algorithmic systems fueled by big data. More and more data is available, more and more powerful algorithms are available. And what these algorithms are doing is they're filtering the data, scoring, making recommendations, making personalized choices easy for you. And all of these things are done automatically. Even investing in the stock market, you don't need anybody. Computers can advise you on how to do these things. And They are also making important decisions about insurance, credit, healthcare, social security, and so forth. When these decisions are made, it is possible that some sectors of the population get favorable decisions, some sectors of the population may get unfavorable decisions. Then the problem is, what are the advantages and disadvantages of leaving everything to the algorithm? Aren't there going to be biases inadvertently inserted into the algorithms by the designers of the algorithms? I may not know what I'm doing when I'm designing the algorithm, but my own personal bias may enter into the system that may discriminate people of one class against the another. This is a problem that is propping up quite often nowadays, and we have to account for it. And then, uh, so these are areas right now that people are looking into. These are called the fat issues: accountability, transparency, and so forth. Related issues to fat issues are what are called causality and interpretability of AI. Any of you who worked with artificial neural nets know that they may make a prediction, but they cannot explain why they made that prediction. That is a problem with many of the AI systems. So the data-driven machine learning approaches are missing an important element of human intelligence. That is, they cannot reason why they are doing what they are doing. They can give you a recommendation that is good, but they cannot explain why. Without that explanation, it is very difficult to persuade other people to follow the line. So, what people are trying to do is to say it is not adequate to develop a uh, correlation between two variables. That means if something A happens, B also happens. That kind of thing is a correlation. What we are more interested is a cause and effect kind of a relationship, so that you can explain why certain activity is being observed. This kind of causality is becoming such an important thing. A professor by the name Julia Pearl, he is a professor at UCLA, he is an emeritus professor now. He wrote a popular science book called Book of Learning. If you get a chance, try to read it. It gives you an idea on what this cause-effect relationship is, how it is driving AI research into the future. Okay. Once you read that book, you will try to appreciate how to explain many of the decisions that AI systems are making. Like, for example, deep networks are well known to identify the image of a cat among a ton of images. But why? Why is it a cat? How do we know about it? Okay. And similarly, if you notice something, what was X caused by Y? What if X had not occurred? That means the cause and effect relationship you should be able to explain by that kind of reasoning. But this is a deep mathematical subject. There is a lot of interest. There are a lot of conferences that are taking place in this area, and you should keep an eye on this area. Okay, now deep learning. For the past 2 or 3 years, deep learning is at the center stage. And most of all, because of its enormous amount of success in image processing and vision. But now people are applying the same techniques to non-vision areas such as natural language processing. Natural language processing has nothing to do with vision, but it is becoming very popular. For example, Google's Smart Compose and Duplex Dialogue is something that belongs to this particular area where deep learning is being used for natural language processing. Facebook's multilingual embeddings is another example in this area. Okay, the final topic is frameworks. Frameworks is a word that we use recently, but we all know about this. Like, for example, if you are using a computer, usually you depend on a language and a lot of tools, libraries, and development environments, and so forth. And a classic example of this is in the machine learning area. We first started with Python. To make it a little easier, you developed a Jupyter Notebook. To make it even easier, you developed scikit-learn. Then came TensorFlow. And on the top of it, we got Keras. All these things are developed in order to make life easier for machine learning people. And is there an end to this? Like, for example, Facebook is coming to as a competition to TensorFlow, is developing something called PyTorch. PyTorch is like TensorFlow, but now there is a competition. Who is going to win this race? Is it TensorFlow from Google or PyTorch from Facebook? Uber, for example, is using a tool called Pyro that is based on PyTorch. All these tools go by the name frameworks, and there is going to be more and more effort going on in trying to make machine learning easier for people so that you don't have to struggle to write the programs. And the latest area, as the first Professor Dhar mentioned, reinforcement learning is now catching up with deep learning. So pretty soon in the near future, reinforcement learning is going to play a more important role. And for example, Google's dopamine is a research framework in order to develop reinforcement learning algorithms. So these are areas that I see are potential activities in the past 2 years, and they will continue probably for the next 2 years. So if you're looking for areas to work, keep an eye on these things. And thank you very much.